Welcome, everyone, to our session. Still have some people coming in. I know I'm competing with lunch, so I really appreciate you guys made it away from lunch early and join us here. We are going to talk today about how to get content to Google TV. And if you guys have been here in the earlier Google TV session, you know that there is nothing that people love more than getting content on their television. So I'm really excited you guys are here, and let's just say you have a big audience for your applications. So that's really good. Let me introduce myself. I'm Kurzke. I'm a developer advocate with the Google TV team. And with me today, we have Andrew.
Hi, my name is Andrew Jeon. I'm a platform engineering manager at Google TV team, covering AV and general platform features.
And Mark.
And I'm Mark Lindner. I'm a tech lead on Google TV's core applications and frameworks.
Great. So those are the guys who actually make the magic happen on the platform. So really cool. So hopefully by now you've all seen the new devices, the new Google TV devices. So if you haven't, go check them out in our sandbox right out on the second floor here. I just want to highlight a few things. So this is the new generation devices from Sony, from Vizio, and from LG. What they all have in common, they are ARM-based devices. And I'm really excited. I know a lot of people outside of the US have been asking us the last year, when can they finally get their hands on a Google TV? And those, or at least some of them, will be available internationally. So Sony has announced they're going international. So keep in mind, when we talk about Google TV devices, we'll focus on all of those devices, and basically the features that we talk about today, they are mostly available on international or on the ARM-based devices, and also international. So what I want you to keep in mind is how people interact with television. And we talk a lot about content in this session. And it's really streaming entertainment, streaming movies, videos. It's really the big thing in the living room. People like to be entertained while they're on the bus, maybe on their cell phone, but they definitely love their content on television at home. There was also another session earlier today by Osama, and he was talking about how to create a beautiful user interface. Of course, you need that too. And then we'll have Paul talk about second screen. But sort of the centerpiece in the living room is really content. It's all about content, content, content. So what I'm going to cover, or what we are all going to cover in this session, is how do you create beautiful content applications for Google TV. Some of the key features for this is you want streaming content. Usually people, they want their content on their fingertips. They want it now. They want access to a huge library of content. How can you ensure that they get the best quality possible? How can you do it securely so that you as a content owner feel secure that content doesn't fall into bad hands? And how can you create a beautiful integrated experience for your viewers? So let's get started and take a look at streaming. So what is streaming really all about? And I'm sure you guys are all developers. You've written code. You know what streaming is. A lot of people, basically, when you do music streaming, you just take an MP3 URL. You have, oops. Uh-oh, that's all right. We'll keep you muted a little. So the HTTP streaming of music, it's not really streaming in the sense as video. And for music, it's actually simple because you can just download and play back at the same time. You basically have enough bandwidth on all devices nowadays to just stream perfect, high-quality music. For video, it's still the bandwidth. We're still in an age where we don't have gigabit to every house, although I've heard people are working on that. But what we really look for in streaming video is how can we optimize the bandwidth that your viewers or your users have to get the best possible content. And so this is just a snapshot from one of my lab tools, but it shows basically when you play back video, you always get bursts of high bandwidth, and you basically load, you buffer. And in this particular scenario, we don't really utilize the bandwidth fully because what happens is there is a lot of times when we don't download any data that we actually could. So we're not really getting the best possible experience to the viewer. And so if you have too low of a bandwidth, you're leaving sort of quality on the table. On the other hand, if you have a higher bandwidth or a higher bitrate encoding than your viewers have access to on their home network connection, then you're actually getting this whole reloading, rebuffering, and let me tell you, people hate nothing more in their living room than looking at a spinning, reloading, reloading in the middle of a movie. So we want to make sure you can do better than that. The other thing that I want to put out there is a lot of people have heard about variable bitrate, and they're like, oh yeah, that's the solution. We need variable bitrate. Variable bitrate is okay. It gives you the best possible perceived encoding for your video stream, but it's actually still one stream. After you're done encoding variable bitrate stream, you end up with one stream with an average bitrate of, pick one, 3 megabit, 5 megabit, 7 megabit. But this is not adaptive at runtime to the network needs that your viewers or your users have. So in an ideal world, if we had all the computing resources in the world, we could encode a stream on the fly for each network connection. The challenge then is the network speed also changes. If you watch a 2-hour movie, and maybe your kids in the back play a game, or maybe your neighbor turns on the microwave and jams your Wi-Fi signal. So your bandwidth might fluctuate even throughout the movie. So what you need to do is you need to be able to actually dynamically adapt to the bandwidth that is available to you while you play back. So how can we do that? The keyword for this is adaptive bitrate streaming. And it's not just variable, but it's actually adaptive. That means we are actually monitoring the playback bandwidth as we play back the movie, and we adjust accordingly. So how do we do this technically? We don't encode the video for each one of the viewers, for each one of you, because that would be a lot of encoding. So usually we have a set of pre-recorded, pre-encoded bit rates. So we have a low bit rate, a medium bit rate, somewhere between 5 or 10 different quality streams. And then we have an XML descriptor, which describes all this. And then in the playback, you basically point to the XML descriptor. The playback stack knows that if the bit rate that is currently playing, there is potential that we could go higher, then it switches to the higher quality stream. If it notices the buffer is getting shorter and shorter, it temporarily can switch to a lower quality stream. On the end, your users and your viewers on the screen see the best possible content that they can with their given network connection. There is nothing we can do. If they have a 2 megabit network connection in their home, they will see 2 megabit quality. But I'll talk to you later how you can actually at least detect this on your end. So there is various standards for this. So I didn't invent this. We didn't invent this. There is, people have been doing this. There is HTTP live streaming, HLS. There is MPEG-dash. There is smooth streaming. And believe it or not, there is a lot more. Because this is cutting-edge stuff, and it's really pushing the boundaries. And companies who do this for a living, they all believe or know that they have the best possible solution for this. So they all tweak the standard just a little bit and push it a little bit one way or another. So we'll talk about that too. So in Google TV, what you can do is our playback stack, our media player, it actually supports playback of adaptive bitrate streams currently in HTTP live streaming format. So if you, for example, in your code, you just use a media player and you set the data source to be an M3 U8 file, which is the XML descriptor that I explained, then we will play back an adaptive bitrate stream. We also support Widevine. So that's basically out in Google TV. If you have one of our boxes today, you can do this. And now I actually want to hand over to Andrew, and he can tell us a little bit more about what the engineers have been up to recently.
Thanks, Christian. So as Christian mentioned, Android as a default, he's been supporting HLS and Widevine media format. But as Christian mentioned, various technique has been introduced by multiple companies. From the beginning, HLS by Apple did a beautiful job of coming up with this idea. And then later on, Microsoft realized that that has a lot of issues. So they extended the protocol and then come up with something called smooth streaming protocol. And we realized that there are a lot of content providers who are using Microsoft format, and we recognized that. And we thought it's very important to support it from our platform as a default without having to do any special thing. So now we are announcing Google TV platform will support smooth streaming protocol from the underlying platform layer without having to do anything from the developers and from the Java application side. So actually, from the developer's perspective, in order to play the smooth streaming encoded streaming content, simply create video player, as you can see, and simply create a video player, and then just hand off data source URL, which points to the ISM URL. Then the underlying video player will handle playback gracefully. And then later on, some content providers got together and realized that, oh, smooth streaming is good, but it's a little bit geared toward Microsoft, as you can see. So they come up with a standard called MPEG-, and then a lot of Hollywood studios are supporting it. So we are also actively working on supporting that from the platform layer. But right now we have HLS and Wi-Fi media format and smooth streaming. Also, there is something called progressive file download, basically downloading a file, and as it gets buffered, you can actually read it and then playback, which is not adaptive streaming. However, even if we keep add these popular streaming protocols, we can actually support everything in the world because, as Christian mentioned, there are a lot of content providers who has legacy content in their backend, so that it takes time to re-encode to a certain standard, or they are already logged into something which we don't support. So there are a lot of custom streaming servers. So how we can solve this problem? So we thought about it, and then the reason for the people who use custom streaming protocol is following. First of all, they may have a special need, or they wanted to add special features to differentiate themselves from competitors. Also, they are so innovative, so even the draft specification is not really done, but the futuristic features they adopt. Or some of them are locked into very old technology. So in this case, how we can do? So we came up with an idea of, let's say if we can create an API which can enable developers to write their own streaming protocol and content parsing, that will be very nice, so that we don't have to embed thousands of streaming protocols in our platform. So from the API's perspective, as you can see, video player interface in Android expects a data source which is URI or string or file descriptors, which means that underlying player implementation should know what this means. So in order to overcome this limitation, we introduced something called Video Source API. So what this API does is, from the Java layer, as an Android application developer, if you have a custom streaming protocol, you can just write Java code to handle streaming, basically getting the data chunk from your streaming server. And then if you encoded this content in a certain container, which is not standard or something we don't support, then you can actually extract the data from your container itself, from the Java, and then end result from streaming and then extraction of the audio video stream will be audio element stream and video element stream. And then you can just push down these two streaming sources to the underlying video player. And then what's going to happen is, although we can delegate streaming handling and container parser, once element stream is being pushed down to underlying video player framework, it can still use hardware accelerated codec and rendering and audio video synchronization and even the PTS video mapping and all kinds of stuff. So we basically separated the portion that developers can adapt to their own proprietary streaming and still use hardware features. So how it works is basically we have a class in our API package called GTB Media Player, which is a subclass of Android standard video player class interface. And we added an API called setMediaSource, and then it expects a class which is extended from either pull media source or push media source. So the reason why we have two different media sources is that depends on the use case. Let's say if you are trying to streaming live content, usually live content is time sensitive, so we have to display the content as it gets arrived. We shouldn't actually delay or buffer too much. In that case, push media source works better, but in most cases of on-demand streaming, you can keep the buffer to keep the quality high. So in that case, you can use pull media source. So both pull media source and push media source inherits from media source interface and then implements basic basic functionalities. And media source is a superclass of those. And then this is a skeleton of the interface. So as you can see, there are multiple methods that it will be called by underlying video player to handle actual streaming pipeline. So if you take a look at the sample, for example, if you want to implement your own video source using pull media source interface, pull media source interface actually implements all of this defined in the video source interface for you for convenience. So you don't have to do anything special. And there are only few APIs you need to implement. So for example, here on DQ access unit is a chunk of data you want to pass down to the low layer video framework. And this event is called when the underlying video framework decoded and displayed all the content from the buffer. So you can keep pulling the data and keep it in your queue, and then your queued data will be dequeued by this event. So that's very simple. So now let's look at the actual sample.
So here's one example application. We were working with a company you may have heard of, SiriusXM. They do satellite radio. And they also do stream their content over the internet using a, custom protocol, because they have very unique needs for encoding their media. And initially, they came to us and they're like, well, we would love to work with you, but how do we support our custom stream technology? And so we worked with them and explained the media source API. And they were actually demoing yesterday on our devices, and I think the quote says it pretty fittingly. They were really able to very quickly develop this application using the new media source API. And the best part was they did not have to develop any native code. They could do everything in the Java layer, in the Android layer. So this was really very easy for them to put their software onto Google TV. So we also, besides all the cool stuff that Andrew has talked about, we also have a few new features in general. So the GTV Media Player class, it also supports multiple audio tracks. It supports, so if you have multiple languages for your video format. And of course, it supports closed captioning and subtitle. So we actually have time text markup language support. And we have also a widget that you can customize for closed captioning. So here's an example what it looks like. And this is very basic. This is just basically rendering TTML on top of a video stream. So now you've seen it's really easy to actually stream to Google TV. If you have your content encoded in any of the common formats like HLS or Widevine or now also PlayReady, you can easily do this. If you have special needs, we have APIs for you to implement support for that as well. So now the question is, how can you make sure the viewers really get the best possible quality, and how can you actively monitor what the viewers actually see? And with that, I'm going to hand it back to Andrew, and we can look at some of the APIs that we came up with.
So let's say you can use all these APIs to support your streaming protocol and your container format, and then you use multi-track audio API to support multiple audio tracks, and then subtitles. And then now you open up a service. So a lot of users are watching your content, and the next thing you are interested in is, what was the quality user was experiencing? The fact that adaptive streaming is relying on fluctuating bandwidth. So at some point in the video playback, the playback quality may be worse, and then at some point it could be better. So how you can actually monitor what was the actual experience? Let's say you have, let's say, 5 track, so 200 kilobit, and then 500 kilobit, and 1 meg, 3 meg, 7 meg, for example. So if a user paid for, like, say, $5 to watch this movie, and then one user was watching all the way from the beginning to the end using 500 kilobit. And then the other user who has relatively better bandwidth has been using 1 megabit. And then at some point, in other part of town, one of the users was able to watch 7 megabps. Is it fair to charge the same amount? So you may want to do it slightly differently. Or let's say a user had a network issue with the ISP, so they couldn't watch the movie in a high quality. So they are claiming, oh, please give me another day. I need to watch it again with a better quality or something like that. But if you don't have a mechanism to measure what was the actual experience, that will be a big issue. So we paid attention to this issue. And then there are 2 things we need to care about. One is actual network bandwidth during the playback, how the network was fluctuating. At the same time, even if network is sufficient, that doesn't mean that user was able to watch every video as it's encoded and which has supposed to be displayed. Let's say video has been encoded in 3 frames per second, but for some reason, user was running something in the background, so how they were so slowed down, so like half of the frame was dropped in the middle. So even if you have a full-blown bandwidth for the content, but if the device was not capable, then actually experience will be affected. So once we have a set of APIs to measure these 2 things, then developers can actually ensure customer satisfaction. And by monitoring all the experience, you can decide whether refund or extend the playback time or do whatever to satisfy your customer. So and also, if application itself has access to this information in real time, you can make a good judgment. Let's say bandwidth goes down to too much and then has been dropping too often, then you can actually recommend user to view it later. Or bandwidth hasn't been able to go up to full 1080p quality for long period of time, then you can actually suggest user, or you have an issue with the 1080 playback, so the user will know, rather than they just complain. So these are the set of APIs we came up with. So set of APIs can measure these things. First of all, actual frame per second data can be measured. Let's say from your Java application, you can kick off a monitoring heartbeat to the underlying video player. So let's say if you want to measure frame per second, then underlying video player, along with the low-level video SDK, to measure actual frame per second in the renderer, so that it can return the information how much frame per second has been displayed to the user. And network bandwidth, as the bandwidth goes down and up and down, we can periodically, whether every second or something, or even if you want to monitor much less often, then you can do that too. And whenever network bandwidth changes, we can report actual bandwidth measured right before that point up to the application. And the adaptive streaming uses buffering technology, and buffer actually changes in size. Let's say at some point, 500 kilobit stream was being played, then buffer doesn't have to be too long. because each chunk is smaller, so buffer can be reduced. And if quality goes up to all the way up to 1080p, then buffer size may get larger to keep, let's say, up to 10 seconds. But even the 10-second high quality video requires bigger memory. And the buffer size and actual filling ratio is very important information. Let's say I allocate 30 megabyte, and then 10 megabyte has been filled. So that's a good indicator for current quality for upcoming seconds. But if we only provide buffer size and buffer fill rate by bytes, there are a lot of work for developers to do, because depends on the encoding quality. You need to calculate how many number of seconds of video is being buffered. So we added another API which can actually return buffered video playback duration, which means regardless of size of buffer, regardless of size of encode, if you just want to know how many seconds of video is remaining in the buffer, then you can actually know that. Oh, 2 seconds remaining, 10 seconds remaining, 0 seconds remaining, regardless of the size. So we thought that would be very useful. And then audio information. So right now, we don't really have a lot of use case for audio information, because usually audio is encoded in a single bit rate. But in the future, if a developer chooses to variate the audio encoding, let's say from 10K to 44K, depends on the network bandwidth. If you want to change the audio quality also to squeeze out every bit of the network, that will be possible. Then you can measure. And in the future, if a developer want to change on the server side, if bandwidth is good enough, then send out 7.1 channel. If bandwidth goes down to little worse than 5.1 channel, bandwidth is limited, then only 2 channel. So we don't really have a use case like that today, but we thought that would be very useful information. So there's API to return that. And default implementation and default setup error codes in Android is quite limited. So we added bunch of extra error code to monitor various error situations. And good thing about this is, once you start monitoring all these variables, you can use analytics framework to send this data back to the Google server, and you can monitor that. So from the coding point of view, there are 2 cases to implement this API. One is using existing Android events, for example, uninfo listener event, or adding our own events. So for example, in case of uninfo listener, this sample shows you how to monitor network bandwidth changes and frame per second and dropped frames. So basically, the same event handler you usually use based on the Android video playback standard. So uninfo listener can receive the event, and then there's extra what type we defined. For example, video info network bandwidth, or video info FPS, or dropped frames. And you can actually create a switch syntax to check that. And then in this case, what is type of the data, and the extra is actual value. So for example, network bandwidth, then extra will be kilobps in integer, and then frame per second is in integer. So you can actually either log it, or send it to your server, or send it to analytics. You can do whatever you want. So all of this sounds good, but if it's really difficult to use, then that's not going to be a good thing for developers. So when we release this API as a package, we will also open source some of the sample code that demonstrates these APIs. For example, we do support smooth streaming in the underlying video framework, but in order to demonstrate the power of video source API, we actually implemented full-blown smooth streaming protocol in Java, and then use the video source API to play. So you will have a full-blown smooth streaming protocol implementation in Java, then you can refer it or change it or whatever you want. And along with the video source API, we support play-ready DRM. So if you have a play-ready DRM server, you can send a license request, receive it, and there are certain conventions to parse that out and then send out the key, encoded key portion back to the underlying framework. to load a key, as a session key, so that when you send out audio-video elements to stream, then underlying media framework, DRM framework, will know how to decrypt and display. And multi-track audio, TTML-based closed caption rendering, and actual rendering code itself will be open sourced. So the sample Christian showed you with the red and little red and italic text, that code is a sample. It doesn't support full-blown TTML spec, but if you are using very rare feature of a TTML, then you can use it in your server side. At the same time, you can extend the rendering widget to handle that. And full-blown QOS API demonstration will be part of the sample, so that you can just take a look and then use it in your application. Okay, now I'll hand it off to Christian.
Thanks, Andrew. So I think this is really awesome. So basically, this is a summary of a lot of the features that Andrew's team has been working on in the platform. And I think it's exciting for developers who create Google TV applications that talk to servers to stream content to their app and to show really high quality videos in their application. And it gives you all the necessary APIs to monitor, make sure the video is displayed properly, and so on. So actually, he already advanced, so wait, there's more. So this is actually something I want to tell you. It's actually a session going on right in parallel, which is unfortunate for people who are here live. Fortunately, all the sessions are recorded, so please check it out when you have a chance afterwards. So YouTube has announced that there is now content APIs, and if you don't have servers to host all of your content, and you can use the YouTube servers and the YouTube infrastructure, and we know quite a bit about how to stream high-quality content. So this is really actually pretty exciting. So you don't need all of the infrastructure backend stuff. You can just use ours, and you can focus on creating the app for playing back this content. So there is an entire session. It's called the YouTube Player API and the YouTube Content API. It's basically going on right now as we speak. OK, so now we've talked about how to get content there. And I'm just going to talk a little bit quickly about how to make sure your content actually stays secure and gets delivered securely. And in the interest of time, you all know what a DRM is supposed to do. I just want to highlight, only because you're streaming your content over HTTPS does not make it a DRM. DRM is a lot more. It's license management. Here is sort of a typical use case where, for example, a Google TV application, it would talk to a commerce site where you browse through a library of movies, you purchase a movie, you have all those transactions. And then you use Media Player to actually request the video stream. The video stream comes back with a license request, and then you deal with a license server, and so on and so forth. And there is a whole, again, just like streaming, there is a whole set of industry standard protocols. And Android actually, in Honeycomb in version 3, introduced the DRM framework, which is really powerful. It is extensible. It's the standard Android DRM framework, which, of course, works on Google TV. So today, we do support Widevine, which is a very commonly used DRM system. And we also, actually, we have been working on some plugins. And Andrew can talk a little bit more about the new stuff that his team has been working for DRM.
So we actually already mentioned the Play Ready, so it's kind of funny that we are announcing again here. But in addition to Widevine, so we added Play Ready DRM as a default to all the second-generation ARM-based Google TV platform. And the way how it's supported is it's still using Android DRM framework as is. But if you look at the Android DRM API, it's so powerful so that you can almost feel like you can do anything. But the problem is it's too powerful, so it's not really well defined for each specific DRM. So in case of Widevine, the way Widevine is accessed is using the same API call, but you still need to know the ID and key pair to operate with the underlying Widevine DRM. So we took the idea of how Wi-Fi was supported and then applied to PlayReady. So once we added the PlayReady DRM in the underlying platform, and then there are certain interaction to work with the PlayReady. So we came up with the convention of ID and key pair to send out all the parameters to the PlayReady DRM in the underlying platform to operate with. So right now, it is already built into Google TV second generation. And then the feature it supports is basic license acquisition and license management. And it can be extended to support custom license server from your application. So let's say if you have your own license server, then you can talk to your license server, basically calling the API to request the license request text, and then send that up to your license server, and then receive the license, and then publish the license into the underlying framework, and then send out the media data so that video data can be decrypted and then played back. And we also, it is already there, but we wanted to mention that even if there is a DRM, if DRM is implemented in the CPU, basically if the code is, all the DRM code is running in the CPU, then it's not really secure, because if a malicious user or hacker gain access to the platform and then gain access to root, then everything in the main CPU can potentially be accessed. So we introduced something called TVP, Trusted Video Path, which means that once the data is decrypted, that decrypted data cannot be accessed by main CPU. The whatever software, piece of software running in the main CPU will not have access to the decrypted data. Usually, there are various techniques, depends on each SoC. The chip vendor has multiple choices, and they make their own choice and then apply their own design. But the data will usually is in the different section of the memory, so that it's protected. And then once data is decrypted in that section, the way the video pipeline works from decryption to decoding to rendering is done through the handle. Let's say you got a buffer with the encrypted data, and then send that buffer to the DRM security module. Then security module will decrypt and keep it in the secure zone, and then returning the handle which points to that buffer, and then hand it off to decoder. Then the decoder implementation should have access to secure area to get to the data, and then decode it, and then uncompressed data will be also stored in the secure region, and then return another handle to point to that, and then send that handle to the rendering piece, so that renderer, usually it could be a FRC in case of TV, or HDMI renderer in the set-top box case, and then send it up to the display, so that we can ensure video protection. And this feature is integrated with smooth streaming and Wi-Fi. So if you are using smooth streaming or Wi-Fi protocol, or any other custom streaming protocol with video source API and PlayReady, it will be protected via Trusted Video Path. So just to summarize, we have an Android DRM framework, which enables you to access DRM feature from the Java application. And once data is decrypted, and we protect it through Trusted Video Path all the way through display unit. And then if the device is HDMI device, I mean either TV that supports HDMI input, or body box that streams in but send out data to HDMI out, we always protect the data inside of the box using Trusted Video Path. And whenever data goes in from our external box or goes out to external box, we are using HTTP content protection to secure the content. Now I will hand off to Christian again.
Oops. Thanks, Andrew. So yeah, I think this is really exciting. So we have now a full set of Java APIs, and I really want to stress this. There is no native code required. You can just stick in the comforts of the Android virtual machine, and you can deliver super high quality content, adaptive streaming. You can even support your custom streaming protocols. We have support for smooth streaming and widevine and HLS. And we have a full DRM system which will keep your content secure all the way end to end. So now how can we make this convenient and integrated to use? So our vision, and our team is working really hard to make Google TV sort of the user interface to your entertainment, to your living room. It's really the way how you get to content in your living room from both broadcast television or satellite or other set-top boxes that are connected over HDMI, or streaming directly digitally over the internet and bringing it to the television. So let's first look at, and I'll browse through this. There was an earlier talk where we did a lot about user research. So we really look how people find content, what they want to watch on their television. And usually people, if they know what they want, then they search for it. If they don't know what they want, they just know roughly what they're in the mood for, they can browse. And we have a TV and movies app. And then how do we get the content? So there's different ways. So one is the back end. You may have heard of that we sort of search stuff on the internet. So we index videos, sitemaps, and everything on the internet. But also on the client side, we actually talk with devices, and we have basically the client side on the Google TV box. We talk with both physical and also virtual devices. So quick graphic, what it looks like. So basically, what we do is we can retrieve a channel list or a list of DVR recordings directly from your set-top box, if it supports it. And we have a lot of devices that are currently integrated this way. And that's how we generate, basically, the TV and movies application, which aggregates all the content that's available from your, in this case, satellite provider. Maybe it includes also DVR recordings that you have made. And it also can, I'll show later how we can get content from the internet into this. And when you change channels, then you just send the command back to the satellite box. So when the user searches, this is what our search experience looks like. This is what our browsing experience looks like. And when you pick a movie and you want to play back a movie, you basically get a list of sources. So for example, this movie that I picked, it may already be on my local DVR. It may be available from Dish, or I can get it from Amazon. And the question that I always get is, well, how can I get my stuff in here? So I am the new and exciting video provider. How can I get in there? And we'll talk a little bit about that. So just to clarify some of the terms, we have one-way pairing, which is the more traditional infrared blasting way of talking with devices. And then when we talk about pairing, we talk more about the two-way case, where we not just change channels on a device, but we also read information back. And I'm actually going to hand over to Mark in a second, and he can explain how we do this, how we integrate one device. So the use case that we're trying to solve now is, OK, you have your Google TV at home. You have a new device that you bought, or as a manufacturer, you're building a new device. How can you integrate this with your device? So, Mark. Let's see.
OK, so we're going to talk about how do you build your own media device. And what a media device is basically it's similar to a device driver. It's a software component that actually communicates with some external device. It's packaged as an APK, and you can install it by downloading it from the Google Play Store. And a media device really consists of three basic components. There's what we call the media device controller service, which is a standard Android service. And this service hosts one or more actual media device controllers. There's a setup activity, which is used to initially pair your device with Google TV. And finally, there's a settings activity in case your device has any user configurable options that can be changed at any time. So this is kind of an overview of our media devices framework. We have the TV player application, which communicates with the media devices service. And the media devices service is a standard component of the Google TV platform. The main job of the media devices service is to coordinate access to media devices. And for each session with a media device, it maintains the instance of the Google TV media player. So all this stuff that's in gray is stuff that's already implemented, and the white portion is what you would implement to create a new media device. So essentially, we have a media device controller service, which hosts the device controller instance, and that in turn talks to the actual device. So the device controller service, as we said, is a standard Android service. It interfaces to one or more media devices. The things it does is notify the system when the device comes online and goes offline. It notifies the framework when the channel is changed on the device and so on. It can also report information from the device, like its channel lineup, its list of DVR recordings if it has them, and so on. So when we implement a new media device controller service, our framework provides a base class for this, so you don't have to build it from first principles. We subclass abstract device controller service, and we fill in some details. The main things we do here is we construct our device object. The device object just basically describes the attributes of the device, its capabilities, and so on. And we construct our device controller instance for that device. So here's a simple example of some hypothetical device with some various options enabled. And the final thing we can do here is we can register a timer to call us back at fixed intervals so we can check for channel updates in case our device is the type that has a channel lineup that can change over time. So now the final thing we implement is the device controller. This is the actual component that talks directly to your device through whatever protocol that device publishes. So one thing we do is we handle user key press events, like if you press channel up, channel down, fast forward on your remote, that gets passed to the device controller for processing. And we also handle tune requests. So if we get one of our TV URIs to tune to a channel or a DVR recording or whatnot, that gets processed as well.
Actually, I just want to quickly highlight one thing, so just to make sure you don't miss the last part of the slide. So basically, when you have this device controller, you can do tune requests to local URLs, TV URLs, or you can go to like HTTP URLs or other URLs using streaming services. So that basically ties back to the first part of the talk where Andrew explained how you can just use the GTV media player to play back streaming media. So the DVR recording that can come either from your HDMI in, from your local DVR, or it can come through a streaming protocol from basically anywhere from the cloud. So this is basically a very elegant way to tie the streaming together and make it transparent, look just like a local device connected in your living room.
Okay, so as we mentioned before, the media device session holds the actual media player instance. So as Christian described, for a physical device that's just connected to an HDMI port, the device controller would tell the session, yes, I want to tune to HDMI port number 2 or whatever that happens to be. But if this is a virtual controller that's representing a virtual device that's streaming media over the internet, it would provide the appropriate URL or data source to the media player as necessary. So when we implement a device controller, again we provide a subclass or a base class in our framework. You subclass device controller, and the main two things you would do here is implement this method perform action, which is handling things like channel up, channel down, or user actions from the remote, and tune to channel, where given a channel number, we need to tune to that channel. So in this case, we would translate the channel number to an appropriate video URI for the media player to play, and then we would call a base class method to notify the framework that we want that the media player instance in that media device session to start playing that stream. So in addition to those things, the typical things you would implement are a setup or a pairing activity. This is just an example of the pairing activity from the Dish DVR integration that we have on our existing devices. So in this example activity, we send a command to the DVR saying, we want to pair. The DVR displays the confirmation code on the video stream, and then the user has to enter that code to accomplish the pairing. And then finally, if you have any user configurable settings for your device, we can implement a settings activity. This is just a standard Android preferences activity that gets installed into Google TV's settings application. And this is, again, an example of Dish Network's, the Dish DVR settings, where we can configure things like the behavior of the fast forward, rewind keys, and so on. And we can also display some status information about our device, like the IP address and so on. And back to Christian.
Thank you, Mark. So basically, just to summarize this, this API, so first of all, if you have a device that is connected to the Google TV, and connected can be used very loosely. It can be either be an infrared protocol that you can speak to your device, maybe it's a legacy device, or maybe you have a more advanced two-way communication capable device. Usually they come with like an Ethernet cord. If you know how to control your DVR device or your media device, you can write a Java layer code, or Java, we call it a media, basically a media device APK, which is all basically sort of like a driver that talks to your device. And you can stay all in Java, no native code required. So you can do all this. And then you can do this, and you can create virtual devices that get the content over streaming protocols using all of our adaptive bitrate streaming, using all the DRM that we have, and bring it integrated to the user. And then the setup and settings activities, they will do device-specific things. So if you need to negotiate an IP address, or if you need to negotiate a pairing PIN, you can do that. Or if you have things like for a remote service, you might have to log in. You need to set maybe a user account and password and so on. You can do that as well. So basically, what that means is we really have one interface to all of your content on potentially all of the devices in your living room, and all of the devices or all of the content that's out there in the cloud. So what that means is if you as a developer, and I think one of the biggest opportunities is really creating applications that bring content to television. So you have access to all the content out there on streaming protocols. So you can use HTTP live streaming. You can use now also smooth streaming. And if that's not enough, you can implement your own streaming protocol that matches your potentially legacy streaming servers or your CDNs. We are compatible with the industry-leading standard DRM solutions. We have support for Widevine. And as Andrew pointed out, now also for smooth streaming and play-ready. We know there is a lot of existing content out there, and it's a huge investment for a company to build up a library of like hundreds of thousands of titles. So we want to make possible that you can adapt or create a custom application to talk to your existing backends. And all of this, even in the Java layer, we have a DRM trusted video path, so you can be assured that your video is really handled in the hardware secure path. So that's pretty powerful. And then to make it easy for the user, you can integrate just as a virtual or real media device. So users have the exact same experience flipping channels through their satellite box as they would have flipping channels through maybe your virtual application. So if you're really interested in learning more about this, we have, of course, our Google TV Plus page. I encourage you to stay in touch. We keep it updated with new information. And of course, as developers, come to our developers.google.com/TV page. And I just want to thank you all. And we take questions. So there is 2 microphones. If you have questions, you're more than welcome to ask us now. Otherwise, we'll be hanging around the sandbox throughout the day. So you can come by and you can play firsthand with some of the devices and can ask us questions. Okay.
Hello. So are there plans to bring these features to the main Android codebase?
Sorry.
Are there plans to bring smooth streaming and the other play-ready features to the main Android codebase?
Do we bring smooth streaming to the main Android codebase? Andrew, do you have an answer for that?
It actually depends on Android team's roadmap and their feature roadmap decision. But we just came up with this, so we haven't had a chance to actually discuss when it's going to be suitable for them to adopt yet.
Okay, thanks.
So right now it's only for Google TV.
Okay.
Yes.
So a similar question, but from the browser, so from the Chromium browser.
So will the streaming APIs be, or will it be possible in the Chromium browser to use the DRM frameworks?
There is a draft protocol, the encryption module protocol, which is in draft and being actively worked on, but it will be different from the DRM API in Android. But there are a lot of working group in our company and also other company as a combined, so working together, but not available to general public yet. It's actually still in the working
the
stage.
W3C proposal, the CDM
Yes.
W3.
So is that the Chrome browser for Google TV or the Chrome browser?
General.
Okay.
Including Google TV. Yeah.
Yes.
Will information from the remote devices like the DVRs, will it also pass control copy information as well once the stream is decrypted?
You mean the control, the copy information
CCI.
from CCI? So the content will come in through the HDMI channel. I assume you mean with the HDCP security bit?
Correct.
So that is basically just an HDMI pass-through. So we would just control the playback, for example, start the playback, but then once the content plays back over HDMI in, we would just basically pass through the device. You guys can correct me. You
Right.
actually
So we don't touch CCI. So
Okay.
if it's a CCI is 1, we keep it 1. If it's 0, we keep it 0, and we don't do anything else.
Okay.
Yes.
Are there any plans to improve the control over video content being displayed? For example, being able to overlay or position TV windows where we want, or that sort of thing?
So overlays and positioning the TV window inside of an application.
So
It's a frequent request.
It is actually technically possible if you use something called media device view as an object, but we don't really have a concrete widget or component type of infrastructure readily available for you to use at this point. But that's something we are thinking about, but we don't really have a concrete timing yet.
So we know it's a frequent request for developers to take the live TV or basically take the HDMI in and embed it in their application. It's one of those things we want to get it right, and we're still working on the proper APIs that we feel confident we can support going forward. With overlays, we've seen Google TV applications that actually overlay over the current screen using things like toasts or toast widgets with custom views and so on. So there is Android capabilities to do that.
Okay.
Next question.
Any time window when you will be releasing the sample code?
It will be later part of this year when the device when our software update for second generation device will be rolled out to the market. We are working with the multiple OEMs, so even if we are done, it's not really readily available to all the device, so it takes some time, but it will be later part of this year. But it will be within this year.
Thank you.
Yeah.
So basically all the APIs that we talk about in this session, they will come with the next software update to the ARM devices. So today in the sandbox, it's not quite there yet, but we're working on basically getting the next generation software update out. And as soon as this launches, we will have all the APIs, the documentation, all the stuff on our developer page. So stay tuned for that.
You know, like we still got to deal with this 4:3, 4:3, and 16:9. Some of the live content which comes in 4:3. Some of the devices, I think I've seen one, kind of like given a button and then you just make it, stretch it to 16:9. Is there any way we can deal with that situation in software or app?
So changing the aspect ratio of the video input?
Correct, 4:3 to whatever, 16:9. So just press a button like normally we have in normal TVs on the remote.
So our platform has an API for OEMs to be able to implement the features to change the aspect ratio. So some OEMs do have a feature to change, some OEM doesn't. But if that's critical, we can actually strongly recommend all of our device makers to follow this API standard to enable aspect ratio change.
The problem with that is that they don't like really implement that. My question was that, is there any way we can handle that software, put that in our APK, and then just tell the users in our own way that, okay, press this button, and that would just like stretch the image?
We will take that as a request, feature request.
Well,
Sorry, I didn't get that.
We can take, yeah.
Yeah, we'll look into this.
Yeah.
We'll note it. Today, I think the answer is today there is no such API available, but I think it's something to look into.
Yeah.
Yeah, it's a great demand, and I mean, people see like all the black sides on both sides, so it's just, okay.
Yeah. So I think if you have feature requests or any ideas, also reach out to us on our developer page. We have what we call an issue tracker, where you can submit ideas and things you want to have implemented. Or you can actually reach out to us on our Google Plus page, and we can start a discussion on it.
All right, thank you.
Thank you. All right, I think we're just on time.
Yep.
Thank you, everyone, very much, and enjoy the rest of your Google I/O.